Hello everyone, myself Jolsna, lecture, Will School of Maritime Studies. So in this session, we will see or we will practice IMUCT based physics question papers. So as an introduction, we know that IMUCT is Indian Maritime University Common Entrance Test, which consists of 200 marks. And in that, English is having 40 marks, mathematics 50 marks, physics 50 marks, general aptitude 40 marks, and chemistry 20 marks. So as you can see from here, we have a weightage of 50 marks. So topics for IMUCT is laws of motion and work, energy and power, properties of matter, electrostatics, current electricity, magnetic effects of electric current, electromagnetic induction and alternating current, dual nature of radiation and atomic physics, nuclear physics, semiconductors. So topics today I am going to cover is electrostatics, magnetic effects of electric current, electromagnetic induction and alternating current, dual nature of radiation, atomic physics, nuclear physics. So our first topic is electrostatics. So what is the difference, main difference between electrostatics and electrodynamics? What is the meaning of statics? Statics means a charge at a stationary point, whereas dynamics means you will study about moving charges. So these are the different theories which is related to electrostatics, which is very important for your IMUCT exam. So first, what is charge? Charges of like two types, positive charge and negative charge, and we know that like charge repels each other and unlike charge attract each other. And what are the properties of charge? So these properties can be asked as a question, like the properties can be applied anywhere in the questions. Quantization, that is q equal to n into e, where n can be integers and e is the charge of electron. So quantization means you are taking as a energy packets, that is one charge is equal to n into e, that is n can be any integers and e is nothing but your charge of an electron. It is additive means you can do the summation or you can add the charges. Okay, so q net charge is nothing but summation of q, and conservation, energy can be conserved, that is total charge of an isolated system will be always constant. Okay, so very important law here is Coulomb's law, which you might have studied, but let's have a recap. The mutual electrostatic force between the charges, suppose you are having two charges q1 and q2, which is separated by a distance r, then the force on the charge q1 will be, that is F1 will be k q1 q2 r12 by r square. So k, you can see that it is 1 by 4 pi epsilon 0, and q is the first charge, q2 is the second charge, r12 is nothing but your cap, that is unit cap, and r square is nothing but your distance. Okay, r12 is nothing but, as I told, it is a unit vector in the direction from q2 and q1. If there are more than two charges in a system, this can be summated actually. The force acting on any charge is the vector sum of the Coulomb force from each of the other charges, and this is known as superposition principle. That means you can add the charges q1 plus q2 plus q3 up to qn, the charges present in the system. Okay, next is your electric field. So electric field is nothing but the region around a particular charge in which electrical effects can be observed, which means you are putting a charge somewhere around a space, and there is a, there is a field around that particular charge in which you can observe a some potential. Okay, so that is known as an electric field, and it has its own existence and is present even there is no charge to experience the electric force. So even if you take a positive charge, you don't want any other charges to get it interacted. It has its own space or it has its own potential, so that it will create a space around itself to provide an electric field. Okay, So electric field intensity is nothing but E equal to F by Q naught. This equation is very important, where F is the electrical force experienced by the test charge Q naught at this particular point, and it is a vector quantity. Okay. Okay. Yeah. So electric field intensity is equal to F by Q naught, where F is your electric force experienced by the test charge Q naught at a particular point. So it is a vector quantity. Vector means it has both magnitude and direction. So basically, if you want to solve a problem, you have to be very thorough with the theory first, because small points may be useful for to solve a problem. So there are some points you have to always keep in mind. So here are the some points to note on this is electric field lines extend away from a positive charge and towards the negative charge, which means most of the like every electric field lines, that is lines of force, will start from positive charge and end to negative charge, and electric field produces the force. So if a charge q is placed in electric field E, the force experienced by the charge is F equal to q into E, which is very basic. And superposition also, so electric field, so before that we discussed that charge is also obeys superposition principle here, whereas electric field intensity is also obeying superposition principle. And electric field intensity due to a point charge, which means only one charge will be there, that is E equal to kq r by r square, where r is the distance from the point charge and r is a unit vector along the direction from a source to the point. So these are the another important equation you have to keep it in mind. So one is point charge. The formula is kq by r square, and the important point is q is a source charge and r is a vector drawn from the source charge to the point. And if you plot a graph where electric field is at y-axis and distance is at x-axis, then your graph will be like this, since your electric field is inversely proportional to your distance, which means as the distance moves, the strength of the electric field will decrease. Now, if a charge is infinitely long line charge, your equation will change, that is lambda by 2 pi epsilon 0 r, which is equal to 2k lambda by r, where lambda is a linear charge density. Suppose the q, all the charges is moving in a wire. Wire means, so each from one end to other end, it is full of charges, which means there is a charge density along the wire. it is represented as lambda. So lambda is nothing but linear charge density. R is your perpendicular distance of the point line charge, and r cap is nothing but the radial unit vector. So if you draw E along E and R along x-axis, again you will get a same graph. Next come, if the charge is distributed uniformly through a ring. So your equation will be equal to kqx by r square plus x square whole power 3 by 2, where q is the total charge of ring, x is the distance of the point on the x-axis, electric field is always along the x-axis, and if you see, this is the graph of a uniformly charged ring, where first what happens, your electric field will increase and a particular point it will get saturated. Then as the distance increases, what happens, your electric field intensity will decrease. Okay. Next, infinitely long non-conducting thin sheet, sigma equal to 2 epsilon 0 n cap. Sigma is the surface charge density. N is nothing but unit normal vector. Electric field intensity is independent of distance. Very important. In this case, non-conducting thin sheet. Non-conducting means you will don't have a, so the charge will be over the surface, but it won't conduct, which means it is not, there won't be a charge density present, which means the electric field intensity is independent of a distance since it is a thin sheet. Okay, so the graph is like this. It will have a constant electric field throughout the, as even if it is independent of the distance. Okay, so infinitely large charged conducting sheet. So this is non-conducting, so it is conducting sheet, sigma by epsilon. Sigma is your surface charge density, and same variables here also you will have a constant graph. And uniformly charged hollow conducting non-conducting sphere or solid conducting sphere. Okay, so your here is, if r is, that is your inner radius, is greater than or equal to outer radius, then E is nothing but k cube by epsilon r square r cap. And if r is less than r, E is equal to 0. R is your radius of the sphere. R cap is vector drawn from the center of the sphere to the test point. Sphere act like a point charge placed at the center for a point outside the sphere, and E is always along radially. So it is like radial, you can see in picture. It is a electric field is always along radial direction, and capital Q is the total charge, which is equal to sigma 4 pi r square, and your graph is represented like this. Okay. Now let's move on to some problems. How to tackle a question in this unit. So work done to bring a unit positive charge from infinity to a point in an electric field is known as, which this is very straight question. It is nothing but your electric potential. Okay. So there are different kinds of question you can expect. One, you can have a direct question. It is somewhat very easy questions will be there, moderate will be there, and little bit tough questions will be there. So first thing you have to see is, so whenever you get a question paper, no matter which subject it is, like, first solve all the easy question, which means solve all the direct questions. Then go for a moderate one, like you put direct equation and doing the normal sum. So there will be some questions which is directly asking from the theory, which you don't want to solve any numerical problem. So this is one such question, which is a very straightforward. Work done to bring a unit positive charge from infinity to a point in an electric field is nothing but your electric potential. Okay. Next one is, if VA and VB are the potential of the 2 points A and B. Suppose you are having a 2 points A and B, and A is having a potential of VA, B is having a potential of VB, then what will be the correct relation between the electric field and potential difference between the points? So the distance between the point is D, and VA is, they have provided one condition, VA is greater than VB. So we always know, always keep it in mind, electric field will be from a point, will always travel from higher potential to lower potential, as in a temperature, as in that, like from highest temperature to lower temperature heat flows. So the same way here, the electric field will from a one point will always travel from higher potential to lower potential, and from this one we have, they have already given VA greater than VB. Therefore, to bring a positive point charge from B to A, you have to do a negative work. Okay, so the work done will be E into, that is electric field, into how much the distance between these 2 points. Okay, so it is minus ED, which will be equal to the potential difference between 2 points. Okay, VA minus VB is equal to minus ED. So answer will be ED. I think minus is missing here. Okay. Next one. By performing a set of experiments, a scientist found that the electric field between 2 points A and B is zero. So, what he can conclude regarding the potential at 2 points? So, we know that VA minus VB is, it's a integration. That is nothing but your work done minus BAE into dx, where E is equal to 0. That is the electric field between 2 points A and B is nothing but 0. So, the whole value become a 0. So, therefore, VA equal to VB, which means VA, since this is 0, VA minus VB will be a constant. So VA, it is 0 itself. So VA will be, VA is equal to VB. Now, calculate the electric potential due to a point charge of 10 coulomb, but a distance of 8 centimeter away the charge. So, this is a direct question. If you know one equation, what first you have to check. So, this is another way. So, suppose there is a numerical problem is there. First and foremost thing you have to check is the keywords. This is a point charge they have given, and then check the variables. What are the variables they have given in the question? So, they have a 10 coulomb charge, which means you can directly, it is q is nothing but 10 coulomb, and also they have given a distance. So now you think about a equation which is related to a distance as well as a charge. So you already have q equal to q by 4 pi epsilon r. So calculate the electric potential. So if you substitute all the values here, you will get a equation answer, that is 1.125. Okay. Next one is a solid non-conducting sphere of radius 1 meter carries a total charge of 10 coulombs. So, okay, so they have given a sphere. So, one thing is a solid non-conducting sphere. This is your one terminology or one key point. So, radius is 1 meter, total charge is 10 coulombs. So, it is also a directive. So, volume of a sphere is 4 by 3 pi r cube. They have given a 1 meter of a radius, that is r is nothing but 1 meter. Okay, so the charge density is total charge divided by this volume. Okay, so substitute all the values here. So since they have given 1 meter radius, charge of 10 coulomb. Okay, suppose they have given all the values here. Directly you can substitute it and you will get a 2.38 coulomb per meter cube. Okay. So this is the end of the electrostatics. So in next session we'll be dealing with magnetic effects of electric current. Thank you.